Today I am going to take the subject of programming with C and C++, which is for the UG third semester students. In this session, I am going to deal with the program design topic, unit 1. In that unit, the first topic is algorithm. But before going to that algorithm, let me tell you the title of the topic, program design. So what is the program? Program is nothing but for any computer. What is a computer? Computer is a machine. It's after all a machine. For that machine will give some work. That work will be processed in the computer and it will produce the result. To do that particular work, that computer will understand that work in terms of program. So that program design we are going to deal today. So to design that program, the very first step is we have to write the algorithm for that program. Algorithm means to make the system to understand the steps. The definition of an algorithm is nothing but it's a step-by-step sequence of steps to follow or else to solve a particular task. Nothing but set of rules, set of precise rules which are used to solve a particular task. So the process of defining a solution in terms of these steps in a specific order to get a particular output is called as an algorithm. Every problem in the world that can be solved using a computer, that has to be represented with a algorithm. That should be written in an algorithm and should be converted into any programming language, and that in that language we have to enter the thing into the computer. So the very first step to solve any program is nothing but giving an algorithm to that program. Algorithms are generally language independent. So for a computer, if you give any task, first it will write the algorithm in a step-by-step process. After that, in different programming languages that we are come across today, in those languages these algorithm will be converted into those languages. So that algorithm is nothing but it's an independent of programming language. To any programming language that we can convert this algorithm. So algorithms are generally language independent. So in order to convert that algorithm in any programming language, algorithm is written in a simple English steps. The main characteristics of an algorithm is, the very first step is, see, whatever the algorithm that we write, whatever the work that we do, definitely it should give some output. So in the same way, algorithm should have, if you write an algorithm, it should give at least one output or more than one outputs it has to give. Then only the task has been completed, that we will assume. The next is, it's not compulsory that we have to give one input to a algorithm. Sometimes we may not give any input to the algorithm. So number of inputs for an algorithm is either 0 or more. If you don't give any input in a particular case also, the algorithm will work, but it has to give exactly one output or more than one outputs. Without an output, the algorithm may not work. Next, the most important third characteristic of an algorithm is, the step that we write in an algorithm should be unambiguous. See, whatever the steps that we write in an algorithm should be more clear and simple, and it should not be a vague sentence. It should give a clear thing. It should not be in a it should say either yes or no. It should not be in an ambiguous state. So the prime thing is, an algorithm should be more clear and unambiguous. Next is finiteness. Whatever the algorithm that we write, it should be terminated in a finite number of steps. it should be terminated in a finite number of steps. It should not go into an infinite loop. Somewhere or another way there needs to be termination for an algorithm. Next is language independent. As we have already seen, whatever the algorithm that we write for a computer should be converted, should be written in any programming language. So, algorithm we will write for any problem should be in a simple English steps. These can be converted into any programming language. So, it is language independent. Let us see one example of an algorithm. Addition of two numbers. This is our program, addition of two numbers. So, as we have already discussed, algorithm is a step-by-step process. The very first step of an algorithm is beginning of an algorithm. That is, the first step is start. And the second step is, as we are adding two numbers, we need to have three variables. We need to have three variables. One variable is used to catch one number, another variable is used to hold another number, and the third variable is used to store the results. That is why in the very second step we are declaring these three variables as integers. Third step is, so first we have to, what I told, first in the first variable we have to collect the value of the first number. So, read value, first we have to read that value and assign that value to the first integer, that is x. Next, read the value and we have to read the second number, because as it is an addition of two numbers, we need two numbers, two integers. So, first first value already we have read and we have kept it in x, and the second value we have read and that should be assigned to 5. So, now we have two numbers, one is stored in x, another one is stored in y. Then we need to do addition. The fourth step is, that is why the fourth step is, as we have two numbers x and y which are stored in x and y. So, addition will be performed at this stage, addition of x and y will be done, and the result after adding these x and y's, the result will be stored. It needs one variable to store the result. So, already we have declared a z to store the results, that result will be placed in z. So, we need to print that result, that itself is an output of an algorithm. The output is printing the addition of two numbers. That is why the fifth step is print z. See, these are the 5 steps that we are following to add two numbers program. See all these steps we are following in a sequential order. If we miss the order, we cannot add these two numbers. Okay, that is why algorithm is a sequence of steps, sequence of set of steps, and as it is, as we have already mentioned, algorithm should be terminated in finite number of steps. It has been terminated in 5 number of steps algorithm. So, all the characteristics that we have discussed for an algorithm have been implemented, have been worked in this algorithm. Is it clear? And the last step is stop. For each and every algorithm, it should be terminated with a stop. It should start with start and it should be terminated with a stop number. And the next topic here is flow chart. Yes, algorithm is a unique one. With that, we can represent a particular program. In the same way, flow chart is also the step-by-step process of representing an algorithm in the form of graphical representation. The same way of, that is how we will write the steps in algorithm. In the same way, we have to write the steps in flow chart, but that should be represented in the form of graphical representation, nothing but pictorial representation that we will call. So, these pictorial symbols includes circle, rectangle, rhombus, diamond and arrows. With these symbols, we can easily represent an algorithm in the form of a flow chart. The symbols used in an algorithm in a flow chart is for the start, for the terminal things that we have written in start and stop. No? So, for that we have to use circle, closed circular rectangle we will use as the symbols. To read the input, we have read the input in x and y, no, in the previous example. So, to read the input, to print the values, we will use that parallelogram. And for the process, we have done the process Like after reading x and y values, we have given the addition of two numbers. No, in the fourth step we have written the addition of two numbers. That is nothing but processing that addition of two numbers. That processing task will be done in this rectangle, and this diamond is used for the decision making. The four corners of the diamonds will be used in such a way that the first corner is used to take the input, the last corner is used to give the output, and the two side corners are used. If the decision is true, we will use one side of corner. If the decision is false, we will use another side of the corner. For that way, we will use the diamond symbol. And the next one is the arrows. Arrows are used to connect all these start, processing, input, output, diamond symbols. We use these arrows. Arrows are nothing but to connect all these sequence of steps. So let us see an example of flow chart. This flow chart is an example of printing the values from 1 to 9. See, the first step is as how we have written in algorithm. First step is start. Start we have written in an ellipse. Next step is we have to read x value. As our question is printing the values from 1 to 9, we have initiated x with the 0. That's why it has been written in rectangle. The next rectangle is we have read the information in x, that is the symbol for rectangle. Next, in the x has been incremented. X is equal to x plus 1. Now your x will become 1. Previously it is 0. 0 plus 1 is nothing but 1. It is 1. Immediately after that, the connector is taking you to the printx statement. The printx statement is used to print the value of x. Now your x value is 1. That x value 1 will be printed. Again it will enter into the diamond one. X less than 10. Is x less than 10? It means when a statement is there in diamond means it will be spelled like this. Is x less than 10? Like that. X is 1. Is 1 less than 10? No. Then it will, if yes, it is 1 is less than 10. Then it will again go to that S part, S arrow mark. That S arrow mark is pointing to x is equal to x plus 1. Yes, x is less than 10. Again we need to go to that rectangle where x is equal to x plus 1 is there. So x will be incremented to 1. Now your x is 1, x is equal to x plus 1 means x is equal to 2. Again it will come down with that arrow mark, print x means x is equal to 2. In the same way again it will come to the diamond place. 2 less than 10, yes it is less than 10. Again it will go to x is equal to x plus 1. This is how it will print till 9. It will print 9, then it will come down. 9 less than 10, yes it is less than 10. Again it will go down, go up, x is equal to x plus 1, 9 plus 1. It will print 10. 9 plus 1 is equal to 10, that it will print 10. Again it will come to the diamond place. Is 10 less than 10? No. So the decision it said is no. Then it will come out of that flow chart. It will represent stop. This is how the flow chart will work. Another flow chart that we can see here is where the diamonds are more used. See, we are finding the maximum of 3 numbers. First we will start with the start. So to find the maximum of 3 numbers, we need 3 variables. One is A, B, C. So in that rhombus we read A, B, C. Then first in the first diamond what we have seen, is A greater than B? If your A is greater than B, then again it will go to the S connector. Again it will verify in the diamond if A greater than B and if A greater than C. Means A greater than B and C. Then among these 3, if A is greater than B and C, it will print again, it will go to the S connector and print A. In the same way, if A is not greater than B, means if A is less than B, it will go to the right connector, nothing but no connector. And if A is less than B and if B is greater than C, means B is greater than A and B is greater than C. Among these 3, B is greater than A and C. That's why it will go to the S connector and it will print B. And if A is greater than B and C is greater than C, then what does it mean? A is greater than B and C is greater than C. So, greatest one is C. That is why it will print C as a greatest or else maximum value. Or else again, if you go top, if A is lesser than B and C is greater than B, then which one is a greater one? B is lesser than, B is greater than A. Again C is greater than B, means C is the maximum one, that is why it will print C. So, it will see all these, the diamonds will see all the 4 different possibilities to find out the whether A, B, C, among these 3 which one is the maximum number. This is how we have got these 3 prints, print A, print B and print B. If you based on the connectivity, based on the values, it will revolve in those decision boxes and it will give you the proper print value. Either it is print A or B or C, whichever is the maximum number. Finally, it will conclude that it is stop. Structured programming. Structured programming is nothing but any programming approach in which the program is made as a single structure is nothing but structured programming. In the structured programming, there is no possibility of jumping the instruction, arbitrary instructions. It will be written in a sequential manner. There is no question of jumping any instruction. The instructions in this approach are executed in a well-defined sequential and structured manner. Almost all the modern languages that we are coming across, that C and C++, Java, C#, Python, etc., all these are of structured programming languages examples. Structured programming languages use the blocks of code and nothing but groups of codes, control statements, iterative statements, functions to make this all the programming as a single structure. A structured programming has a single entry point like how we have discussed in algorithm and it terminates at a single exit point. Structured programmings are nothing but they are very comfortable and they are very easier to read, understand, and if any errors occur, easy to debug and easy to maintain also. Development of software also becomes very easier if you write the programming language in a structured programming language, and it takes very less effort since all this code can be reused and which is less prone to errors. Though if errors occurs, debugging is also very easy in the structured programming languages. What are the unstructured programming languages? The old programming languages like BASIC, beginners all purpose symbolic instruction code, and the Fortran, formula translation. These are the old languages like this. BASIC and Fortran are the best example for the unstructured programming languages where the flow of steps are not sequential. They can jump from one statement to another statement. With these unexpected jumps can be possible with the help of go-to statements. These kind of go-to statements will not be there in the structured programming languages where it will follow the sequential steps. These unstructured programs are very lack of reusability and readability of the code. Reusability and readability is the very good features of a good programming languages. So, structured programming language can be treated as a good programming language, unlike the unstructured programming language where we lack the reusability and readability of the code. Yes, as we have already seen one algorithm, that is finding the maximum of 3 numbers. We will see another best algorithm with which you will understand what is the algorithm perfectly. So, best example here is we'll find the algorithm for the binary search. Searching is the most important data structures that we use. So, what do we search? So, what do you mean by searching? Searching an element means finding an element among some set of elements. So, in binary search, the input of an algorithm that we take is some set of elements, some set of numbers we will take. In those numbers, we will search one of the number in those numbers. But the very important point here is input we will take the set of numbers which are already in a sequential order. Means the ordered list of elements we will take as a input for the binary search. So, the first step is a sorted list of n elements, and one more element we want which we wanted to search. So, that we will place in element x. So, we need one target element, we need some sorted list of elements. Okay. And the next step is initializing the variables. So, in order to go with the binary search algorithm, so first we have to initialize the variables. We will index the first variable as the lower index and the last variable as a upper index. The lower index will be initialized with 0 and upper index will be initialized with n minus 1. As we take n number of elements, so upper index will be n minus 1. For example, if we take 10 elements, the first element will be indexed with 0 and the 10th element will be indexed with 9. First element will be indexed with 0 and the 10th element will be indexed with 9, nothing but n minus 1. And the mid element is this low plus high by 2. We have to find out the mid element in the binary search, lower index plus higher index by 2. Here the lower index is 0, higher index is n minus 1. So, 0 plus n minus 1 by 2 is the middle element. So, now we will start the loop. As we wanted to search the element x, so we have to find out the main point in the binary search is finding the targeted element, the element that we wanted to search, whether it is there in the first half or in the second half. How to find whether it is there in first half or second half? So, first you have to divide the number of elements into half of the elements with the help of this mid index. So, lower index to mid index is first half, mid plus 1 to higher index is the second part. So, we have to divide the number of elements into half of the number of elements into 2 sets. Then we have to find out our target element whether it is there in the first part or in the second part. That is our main process of the binary search. So, the next step is while the low index is lesser than or equal to the higher index, repeat the following. When that lower index will be lesser than or lesser than the higher index? When suppose if there are only one element is there, that itself is a lower index, that itself is a higher index. So, means lower index is lesser than or equal, means equal to the higher index, means the search is over, there is no element in that. Okay, that is why it will stop the loop. Okay, this is how that we have mentioned in the start loop. Next, the compare that with the mid element with the x. So, we have taken lower index, higher index and mid element. No, you have to compare that element with the mid element, because as the number of elements that we have taken are in the order, in the sequential order, whatever the elements that we find in the first half will be the lesser elements, whatever the elements that we get in the next half will be the higher number of elements. So, suppose if your targeted element is lesser than or equal to the mid element, your element, the element that you wanted to search will be there in the first half. If the element that you wanted to search is there in second half, definitely that element will be found in the second half as the elements are in the sorted order. In that way, we have to compare all the time our targeted element with the mid element. If it is lesser than mid element, you should compare it, you should search the element for in the first half. If it is greater than the mid element, you should search for the element in the second half. Suppose if your element is there in the first half, then leave about the second half, because you are confident that in the second half the element is not there. Only take the first half of the element. In the first half of the element, anyway you will have the lower index, but the higher index will be treated as, because the higher index has gone in the second half. So, you have to again re-index the higher index. The higher index will be your mid minus 1, your mid minus 1 if you wanted to search in the first half. Lower index will be as it is, higher index will be your mid minus 1, because you wanted to search in only the first set, you are leaving the second set. So your searching elements has been reduced. This is the best part of the binary search. So your searching has been reduced to half. You are not searching in entire 10 elements. You are searching in only 5 elements. So that is how you are reducing the size of the elements, the searching size of the elements. So when you are searching in the first half of the element, lower index will be 0, higher index will be mid minus 1. Suppose if your target element is greater than the mid, so you have to search in the second set of elements. In the second set of elements, higher index will be anywhere there. You have to re-index the lower index. That lower index will be the mid plus 1 will be the lower index. In the first part, the higher index will be mid minus 1. In the second part, the lower index will be mid plus 1. Higher index will be the higher index that we have declared at the beginning. So this is how you have to update the lower index in the second half, higher index in the first half. So again in the reduced set of elements, again you have to find the mid element. So your mid element will be the lower index plus re-initialized, re-indexed high number will be there, no? That will be, both will be plus, and you have to take the average among those 5 elements only. Again the same old process will be repeated till your number of searching elements will be reduced to 1. If the number of searching elements will be reduced to 1 means if it is either equal to or lesser than 1. If it is equal to 1, then the target element that you wanted to search is that element itself. If the reduced number of elements size is only 1, that itself is your targeted element. If its size is less than 1, nothing but there is no element left over in the search, in the elements, means your targeted element is not there in the list of elements. If it is there in the list of elements, it will be found in the last midpoint. If it is not there in the list, then your lower index and higher index will be both are equal. This is how the binary search will work. The index of x in the list will be identified either as the lower one or the higher one. The output is that you will, if you find that element, you will place that the element that we wanted to search is found at the midest position. Otherwise, you will give the output as the element is not present in the given list. See, let us take the example. So we have taken the numbers from 0 to 9. See the numbers 2, 5, 8, 16, 23, 38, 56, 72 and 91. These are there in the sorted order, that how we have said in the algorithm, no? So these are the sorted list of elements. How many number of elements are there? 10 number of elements. What is the lower index? Lower index is 0, higher index is 9, means 10 minus 1, n minus 1 is 9. So higher index is 9. 9 index is indicating the 91 element, 91 number, 0 index is indicating the 2 number. So these are the lower index and higher index elements. So our target is to search the number 23. Okay, so in order to search the number 23, what we have to do? First we have to find out the mid element. What is the mid element among all these? See, lower index plus higher index by 2. Lower index is 0, higher index is 9 by 2, that is nothing but 4.5. So we will round it to, truncate it to 4. So your index will be at 4. What is the element that is there at the mid position? Fourth mid position, 16 number. The element that is there in the mid position is 16. Just compare that 16 with your target element. Your target element is 23 and your number you wanted to search is 23. So it will be there in the second half of the elements. So it is not there in the first half of the partition. Your 23 is not there in the first half of the partition, as your target element is greater than your mid position. Then go with the second part of the elements. Just leave the first part, because as we already concluded that it is not there in the first part of the elements, first half of the elements. Then your lower index will be incremented to mid plus 1. So, already your lower index is 0, mid element is 4. So, it will be incremented to mid plus 1 as how we mentioned in our algorithm. So, your lower index will be mid plus 1 means 4 plus 1. So, now your lower index is 4 and higher index is 9. Okay. Then again you have to take the same or repeat the same old process of doing the finding the mid position. Lower index is 5, higher index is 9 by 2, 5 plus 9 by 2. So, it will be rounded to 7th position. So, what is the element that is there at the 7th position? 56. See 56, 23 is 23 lesser than 56? Yes, it is lesser than 26. Then it will be there in the first set of the elements. That means in between lower index and mid index. So, lower index is 5, mid index is 7 and it will be there in between this lower index and mid index. Again you have to repeat the same old process. Lower index is 5, mid index is 7 and you have to do the low plus mid by 2, 5 plus 7 by 2. Again your midpoint will come to 6. You have to repeat the process again and again, and in the next step your lower index will be 5 and mid index itself is 5. Your lower index and mid index are equal to the same number that you are trying to search, that is 23, which is equal to 23. That is how your search ends. You have find this element in the 6th iteration, 6th process of dividing those elements. You have reached to the element 23, which is your targeted element, the element that you wanted to search. This is how the binary search works in an algorithm. This is the best way that you can express the binary search in the algorithm.